Can you solve this question from IIT JEE 2012? This question is a combination of quadratic equation and limits, but the limit is very simple if you look. So it says that the quadratic equation has two roots, alpha and beta, and we have to find the limit of alpha and beta when a approaches 0. So what if we just so now if a approaches 0 and we try to put that in this equation, then what will happen? This 1 plus a, whether it is whatever be the power, it tends to just 1 when a approaches 0. So what will happen is, like, this term will be 0, this will be 0, this will be 0, and the equation disappears. So this is not the solution. So we have to first understand how we can simplify this equation. If we look carefully, we can see that this is 1 plus a to the power 1 by 6, this is 1 by 2, this is 1 by 3, and you can see they are like linked, 6 is multiple of both 2 and 3. So one way is that we assume this 1 plus a to the power 1 by 6 equals to b. In that case, 1 plus a cube root equals to b square, and square root of 1 plus a is b cube, and we put this value in the equation and we have b square minus 1 x square plus b cube minus 1x plus b minus 1. And now we can see that we can take b minus 1 out, right? So if we factorize this, so we will have b minus 1, b plus 1 x square plus b minus 1 b square plus 1 plus bx plus b minus 1 equals to 0. And we can take b minus 1 out, so we will have b plus 1 x square plus b square plus b plus 1 x plus 1 equals to 0. Because b is not exactly equal to 1, so we can remove this. So ultimately we will be having b plus 1 x square plus b square plus b plus 1 x plus 1 equals to 0. So this is our final equation. And here we can see that we have to find the limit, right? So one way is we find the roots and then we find the limit. Another way is here we try to put the limit, because this will simplify the equation a lot. So what we can do is, we know that as limit a tends to 0 plus of b is just 1. So if we put this limit in this equation, we will have 2x square plus 3x plus 1 equals to 0. And these roots of this equation are very simple. The final answer is B. That's it. If you enjoyed this solution, consider subscribing this channel.